instantaneous rate of change. Last lesson we learned about the average rate of change. And now we're going to find the instantaneous rate of change. Now, let's find the slope of the parabola y equals x squared at the point 2, 4. You'll see right here, there's my parabola, and in red, the dots is at 2, 4. I want to find the slope right at that point of the parabola y equals x squared. And we got to use our friend here. F of x plus h minus f of x all over h. Now, I'm going to be using x squared as my function. So I've got to put an x plus h into x squared, then subtract my original function, x squared, all over h. Now let's not forget, this is the limit as h approaches 0. Okay? So it's x plus h squared minus x squared, right, all over h. Well, let's FOIL this out first. So let's FOIL this out. Okay? We have x squared plus 2xh plus h squared. Then we have minus an x squared all over h. Now, if we've done this right, this whole back function, whatever it is going to cancel it at this point right here. Negative x squared with positive x squared, and it's done. Now I can cancel my h. The h in the denominator cancels with one h in each term in the numerator. Okay, so I'm left with 2x plus h. So ultimately now, I have the limit as h approaches 0 of 2x plus h. I could not substitute my h in before here. 0 is in the denominator. That makes it undefined. I couldn't put a 0 in here until I canceled it out. I can now put my 0 in here. But what about my x? What do I do for my x? Here's my x right here. That's a coordinate, isn't it? It gives you an x and a y. I want the x. So I'm going to put that in for my x. 2 times 2. Well, the slope is 4. There's a slope of 4 right at the point. And if we were to draw a tangent line, that tangent line there has a slope of 4. This line right here has a slope of 4. Let's take a look. If I start right here, I go up 1, 2, 3, 4, then over 1. It is exactly right. It goes up 4 and over 1. That's perfect. So basically, it's the slope of the tangent line. That's what we just discovered, isn't it? When I find the derivative with my f of x plus h minus f of x all over h, if I find the slope at a point, that's basically the slope of the tangent line we create at that point. All right, so now that we found the slope of y equals x squared right at the point 2, 4, let's find the equation of that tangent line. Okay? Let's find the equation of this tangent line right here that we created. All right? I want the equation of that. Well, there are 2 equations of lines that we use. One is the slope-intercept form, and that's what we're really familiar with from previous classes. What we've learned, in more recent math years is this point-slope form. And in calculus, that is going to be so much more helpful and a lot less work. Let me explain. Well, based on the work we just did, we figured out the slope of that tangent line was when we took the limit as h approaches 0 of f of x plus h minus f of x all over h of the function x squared. We got the slope to be 4, didn't we? We sure did, if you remember. It's right here. That's our slope. Okay? So now our slope is 4. And if we know that, we know that m is our slope. I'm going to put a 4 here. Also, that's right at the point 2, 4. That's right at the point 2, 4. So I have an x and a y, and my slope we have is also 4. So why don't we just plug these in? This is the way we used to do it in 8th grade, 9th grade, 10th grade. Y is 4, and x is 2 plus b. So we have 4 equals 8 plus b. I subtract 8 from both sides. I get negative 4 equals b. So now I have my m, I have my b. I'll just plug it into my equation. I get y equals 4, which is my m, x, and my b is negative 4. So the equation of that line is y equals 4x minus 4. Now let's see the point slope formula. Now, just like any equation of a line, I always need a y and an x in there. I always need a y and an x. Okay? Here's the y that I'm going to keep, and here's the x that I'm going to keep. So the only thing I need is my slope, all right, which is this, and I need a point. I need an x and a y coordinate. It's the same thing here. I mean, that's why it's called point slope. This one's called point or slope intercept because I need a slope and an intercept. All right? So, y minus, well, I have a y, 4, equals m 4 times, I keep my x, minus, I need an x coordinate, I have one. There you go. That's an equation of a line right there. There's so little math because I already have the pieces. I'm just plugging them in. So let me reiterate here. As long as I have a coordinate, there's my x, there's my y. And as long as I have a slope, there's my slope. That's it. That's all I do. Now, how do we know they're the same? Well, if I take this equation and set it equal to y, it should end up with the same thing I get here. Let's do that. If I distribute the 4, I get y minus 4 equals 4x minus 8. Now, to get the y alone, I have one more step to perform. That's adding 4 to both sides. Y equals 4x minus 4. It is the same thing. So guess what? This right here would be a good enough answer. Unless they specifically tell you to put it in slope-intercept form. If they just ask you for an equation of a line, this point-slope form is fine. The only reason you would have to do it another way is if the question were to ask you, give me the equation of the line in slope-intercept form. Then you would have to get the y alone. Now, let's take it a step further. Let's find the equation of the normal line. The normal line is the line perpendicular to the tangent line. This is perpendicular to the tangent line. All right? Now, what would that look like on our graph? That line in blue is the normal line. It forms a 90-degree angle when it intersects the tangent line. How do we come up with the equation of that? Well, let's do the easy way. Let's use our point slope. Y minus y1 equals m times x minus x1. Do I have a point? I do. It's going right through the same point here. If I were to extend this normal line through, it would come right through here. Okay? So guess what? It still goes through that point. That big, nice dot here at 2, 4. It still goes through it. So I can still use an x and a y as 2, 4. We're still good. The slope is obviously not the same. Okay? The slope of my red tangent line, this had a slope of 4. So what's the slope of my normal line? It's definitely not 4. In fact, it's not even a positive slope. The red line is positive slope. The blue line is a negative slope. So we need to go back to geometry and remember that if I know the slope of a line is 4, this is the slope of the tangent line, then the slope of the normal line, or any perpendicular, it's the negative reciprocal. Which means, if this is 4 over 1, I got to negate it to make it negative 4 over 1, and then I got to do the reciprocal of it. I switch the numerator and denominator. It becomes negative 1, 4. So the slope of my normal line is negative 1, 4. Okay? Once a line is perpendicular, as it goes from here, the slope will go to here. It is the negative reciprocal. Oh man, look at me. I now have a slope here for my normal line. It's negative 1, 4. So, let's just plug in some numbers. We keep our y, because we always need a y and an x in our function for a line, minus, what's my y coordinate? Still 4, equals, what's the slope of the normal line? Negative 1, 4, times, I keep my x, I always need an x, minus my x coordinate. And that is it. And if you wanted to make that into if you want to make that into slope-intercept form, I just set it equal to y. I'll have to distribute my negative 1/4, then bring over the 4. But since this question doesn't ask for it, I'm all done. All right, the last problem. Let's find the equation of the tangent line and normal line of the equation f of x equals 4 minus x squared at the point x equals 1. All right? Now, I don't have a coordinate. That's fine. I still have an x value. That's all I really need. So, how do I find the slope of the tangent line? Well, that's f of x plus h minus f of x all over h. It's the limit as h approaches 0, and it's at the point where x equals 1. All right? So, now when we input our x plus h for x, we can't forget, we still have a 4 and a minus in front of it. So I'm going to say 4 minus x plus h squared. All right? Minus the original function. It's the whole original function you're subtracting, so don't forget your parentheses. And if we do this right, this part right here in the back is going to end up canceling with the part in the front after I FOIL it and expand it out. All right? So, let's go to work. We have 4 minus x squared plus 2xh plus h squared. That's what happens when I FOIL this part out. I'm going to distribute this negative, and I get minus 4 plus x squared all over h. Now, I still have to distribute my negative right here. This still has to be distributed to all 3 of these. So I'm just going to quickly rewrite this. You could have done it in the one step, but I just want to show you guys as we go step by step. Right? So it's 4 minus x squared minus 2xh minus h squared. I've just distributed my negative, and I got to finish writing the rest. Minus 4 minus x squared all over h. All right? Let's see if we did this right. Ooh. This is a plus here. I got to make this a plus. Okay? So let's see if we did this right. We have a negative 4, a positive 4, that's good. And, oh, good thing I changed that. A positive x squared with a negative x squared. I did that correct because everything left in the top has an h that I can cancel my denominator with. This goes into this term and goes into this term. I cancel an h each. So I have negative 2x minus h left. Negative 2x minus h. This is as h approaches 0 at x equals 1. So negative 2 times my x, which is 1, minus my h, which is 0. My slope is negative 2. That's the slope of my tangent, right? So let's go all the way back up here. The slope of my tangent is negative 2. All right? I have an x, I need a coordinate, right? I have an x as 1 because it's given to me, but how do I get a y? I use this right here. Don't forget, f of x is almost the same thing as y, isn't it? So if y equals 4 minus x squared, and my x is 1, well then y would equal 4 minus 1 squared. So y would equal 3. So now I have my coordinate. Now it becomes really easy using the point-slope formula. Y minus y1 equals my slope times x minus x1. All right? Well, I keep my y, and I keep my x. Well, what's my y coordinate? It's 3, so minus 3. My slope is negative 2, and my x coordinate, I subtract that, it's the 1. That is absolutely perfect for the tangent line. Now, what about for the normal line? Everything is exactly the same for the normal line. The only difference is my slope. Everything is exactly the same here and here. The only thing is my slope, now that it's a normal line, let's not forget it is the negative reciprocal, right? Because it's perpendicular. So negative 2 over 1 becomes positive, and I flip it. It becomes a positive 1 over 2. And guess what? That's my slope. That's my, equation of my normal line.